last time.
Cosine squared of theta equals -1 plus cosecant squared theta.
What was the last number?
12.
12? 13. Sum and difference formula. Let's look at cosine of A plus B. This is cosine of A, cosine of B, minus sine of A, sine of B. 14. Cosine of A minus B is cosine of A, cosine of B, plus sine of A, sine of B. Observe the twist, the signs. 15. Sine of A plus B is sine of A, cosine of B, plus cosine of A, sine of B. 16. Sine of A minus B is sine of A, cosine of B, minus cosine of A, sine of B. 17. Tangent of A plus B is tangent of A plus tangent of B over 1 minus tangent of A times tangent of B. Tangent of A minus B is tangent of A minus tangent of B over 1 plus tangent of A tangent of B. Once you start studying these formulas, you will see that they are pretty easy to remember. They just, practice. That's all. So 5-2, we have three problems to do. If you was king, it's safe or something. Okay. Page in question is 272. let's also say we only give you what, 2, 4, 6 formulas, but actually you have 12 because knowing the cosine, you know the secant. Knowing the sine, you know the cosecant. Knowing the tangent, you know the cotangent. Okay? Because they are reciprocals. Right? We only give you these. This is just like giving you 12 formulas, but we just give you 6. The others are reciprocals of those. So just keep that in mind. Here, you asked to find, use the exact values. Whenever they say use the exact values, you're gonna find a combination of 30, 45, 60, 90. Okay? Whenever we say do not use your calculator, some people think that they're smart, they're using the calculator. No. When we say do not use the calculator, that means we want you to provide the answer with the square roots and the fractions and all that. Okay? We ask you to use the exact values to come up with the exact answer for this one here without the calculator. When you look at the exact values of angles, what combination of any two of them will give you 75? 30 and 45. So when we're looking at sine of 75, we say sine of 75 is the same thing as sine of 30 plus 45. This is still 75, do you agree? But we're going to apply now sine of A plus B to solve it. And which formula is this one here on the board? 15. That is going to be sine of 30 cosine of 45 plus cosine, sine of 45. I'm sorry, well, let's just put cosine first. Cosine of 30 and sine of 45.
Does it really matter which way you put those last two?
And multiplication is commutative.
Yes.
Okay? 2 times 3 is the same thing as 3 times 2. For this one, the reason why I say it doesn't matter here because these are going to be numbers. But you will see towards the end of this section, this chapter, when you flip it, it's not always going to be the same. When it's a formula. But if it's a number, then it's no problem. Sine of 30 degrees what? Anybody? 1/2. Sine, cosine of 45 is what?
32.
Square root of 2 over 2. Cosine of 30 is what?
3 over 2.
Square root of 3 over 2. Good job. Sine of 45? Square root of 2 over 2. From there, you'll be dealing with the square root of 2 over 4 plus the square root of 6 over 4. Since they have the same exact denominator, you say square root of 2 plus the square root of 6 over 4. And that's the way we want you to provide the final answer with the square roots. Not decimal values, the exact value, which is that one. Any questions? All right, that was number 2. This is the exact value. Next, number 12. You asked to prove that this thing here is an identity. Number 12 and 18, you asked to prove that they are identities. That means prove that the left side is the same as the right side. Whenever you see the sum or difference of two angles, that side that contains the sum or difference, that's the side you work with. Meaning, for number 12, we're going to have to work with the left side to prove that it's the same as the right. Well, working with the left, what type of formula are you going to have to use here? Anybody? Number 16. Sine of A minus B. And we said this is going to be sine of A, cosine of B, minus cosine of A, sine of B. Where A and B are the values inside the parentheses. A is this one here, B is this one. Now, what is the value of cosine of pi over 2, which is 90 degrees? 0. Wonderful. Minus cosine of x times, what is sine of 90 degrees? 1. Wonderful. So sine of x times 0 will be 0, minus cosine of x times 1, which is cosine of x, equals to k. Oh, what did we need to prove? Oh, negative cosine, which is what we have on this side here, that we're done. Yes.
Cosine pi over 2, 0.
Yeah, I wanted the same question.
I don't think.
Exact value table that I gave you.
Oh, okay,
Yeah.
I was thinking of something.
Cosine pi over 2, okay.
We have to know them, okay? Okay. Number 18. If you don't mind, I will start number 18 here. Again, we have the sum or difference on one given side. That's the one that we're going to work with. We have tangent of a minus b. Which formula is this one among the formulas on the board? 18. Okay, we'll do exactly what formula number 18 says for the left side. It is tangent of x minus tangent of power 4 over 1 plus the tangent of x times the tangent of power 4 equals to k. Tangent of power 4 is what? 1. That's tangent of 45 degrees, which is 1. So it's tangent of x minus 1 plus tangent of x times 1. While on the top, you're left with tangent of x minus 1. And on the bottom, you're left with 1 plus tangent of x. Well, wasn't that what you were trying to prove? Yeah, exactly the same thing. And you're done. Questions?
Hold on just a second.
Yes.
When you plug in b, it doesn't have to be negative, because it's like x minus pi over 4.
Formula number 18. Did we say negative b?
Oh yeah, sure. But will it
B
always
is the value, not the sign.
Alright.
The sign is in the formula. B is the value.
So regardless of what that says, you go by the formula.
Yeah. B is not negative. It's not a negative number. B is the value.
Alright.
A is a value. Just pull the values out. $22. The question for number 22 is to simplify this expression. Yeah. Write this expression as a single trig expression. Let's look at the formulas that we have here and see which one of them that we could identify with this expression.
14.
Which one?
14.
14. Formula number 14 is the one that has cosine of A, cosine of B, plus sine of A, sine of B. Do we all see that? It is the right side of formula number 14. Now they asked you to write as one expression, then this is going to be the left side that we have for number 14. Meaning, this is going to be cosine of A, which is 3x, minus B, which is 2x. And that is cosine of x. This is how you would write number 22 in the simplest form. Questions?
So pretty much you just throw out the other half, the sign part. And you
Yeah. Whenever they ask you to simplify, what you do, essentially, they will give it to you on the right side. It's up to you to simplify it into the left. The left side is some simplified form of the formula. The right side is the expanded form, I would say.
So if it was like 15, you just really take your sign values and plug in.
Yeah. Sine A plus B, if it was 15. Since it's 14, why do we say it's 14? Because it's cosine plus And there's only one formula that is like that on the board. Number 14 is the only formula that is like that. Cosine, cosine, plus sine, sine. And they will always make sure the angles are repeating themselves, so you identify clearly, this is A, this is B. Next is 30. Number 30 is the same idea that's going through number 30, but it has to do a little bit more from number 30. For number 30, you have to graph this one. Since you just have a test on chapter 4 and you know how to graph pretty well, I'm not going to do the graph in class. However, in your homework, you need to do the graph. And in the test, when I ask you a question like that, you need to provide a graph. Okay? But I'm just going to show you how to simplify it first. When you look on the board, what formula looks like this one here? Again, 14. Because it's cosine, cosine, sine, sine. Do you see that? However, number 14 doesn't have a coefficient in front of it. So before you can identify this one with number 14, you have to factor out that first, okay? Factor the common coefficient. So we say first we're going to factor out. We'll say y equals to 2 times cosine 4x cosine x plus sine 4x and sine x. From there we can observe that this is A, this is B, this is A, and this is B. Now the formula goes, number 14 goes cosine of A minus B. So we say this is going to be y would equal to 2 cosine of A minus B. Which we know 4x minus x is what? 3x. Now, although I'm not going to finish this up, but you have to finish it in the test and also in the homework, let's talk about this one for a second. What is the amplitude of this function? 2. What's the phase shift?
None.
0. That's where you started, right? At 0. You started at 0 because there's nothing adding or subtracting from the x value. What is the period of this function?
2 pi over 3.
2 pi over 3. What would be the multiple to use in this for this one?
2 pi over 3.
Which is? Pi over 6. So these are the things that you need to know to come up with a graph. All right. 30. For 38, you were given pieces of information and it has to come up with secant of A plus B. Observe that you don't have a formula that says secant of A plus B. However, which one would you use here to solve this one? 13. Okay? The reciprocal of that will give you the secant, agree? So it's 1 over the cosine. To be able to use number 13, I need to have cosine and I need to have sine of each angle, which is not something that I have here. What they gave me here are the secant and the cosecant and the secant of each angle. Then I'm going to pull out the right triangle to see what's going on. Always the way to deal with this one here. Not the only way, but the best way. Secant is the square root of 5. Secant of A is the square root of 5. When you have the secant, which sides do you have? Hypotenuse over? Adjacent. So we have the hypotenuse here over the adjacent, because since it's only square root of 5, it is square root of 5 over 1. Do we all get that? What must this side be?
C squared minus D squared.
Which is 2. Another way to look at it, this is the sum of the square of the 2. 2 squared is 4 plus 1 is 5. Okay? That is something that I gave you the first day. So I'm pretty sure you all can see that. Now let's pull out everything that we do know from this one here, because we need the sine and the cosine of A. So what is cosine of A? 1 over square root of 5. What is the sine of A? 2 over square root of 5. Opposite over hypotenuse. It's all chapter 1, okay? Let's talk about angle B. Again, we were given the secant. So this is going to be the square root of 10, and this is going to be 1. What must be the side? 3. What is cosine of B? Anybody? 1 over square root of 10. What is the sine of angle B? 3 over square root of 10. Now we have all the information that we need to process this problem. Let's write them down. We say secant of A plus B is the same thing as 1 over the cosine of A plus B, which is 1 over cosine of A, cosine of B, minus sine of A, sine of B. Now that we know all of them, let's just replace them by their values. It is 1 over cosine of A is 1 over square root of 5. Cosine of B is 1 over square root of 10. Minus sine of A, 2 over square root of 5. Sine of B, 3 over square root of 5. Sorry, square root of 10. Okay, now let's just simplify this expression. Well, at this point we'll be looking at 1 over, when you multiply this out, what do you get? 1 over square root of 50, square root of 50 is what? You get 1 over square root of 50, but for square root of 50 you can find a perfect square that will be 25 times 2, agree? So this is 1 over 5 square root of 2. That's the first one. The second one would be 6 over square root of 50, which is 6 over 5 square root of 2. All right? So that's what we have to play with. Let's write them down. 1 over 5 square root of 2 minus 6 over 5 square root of 2. Okay, before you can play with these fractions, you have to unite them. Given that they have exactly the same denominator, uniting them is not going to be a problem. Just combine them together, okay? 1 minus 6 is what?
5.
Negative 5. So we will have so far that the secant of A plus B would be 1 over negative 5 over 5 square root of 2. Well, because of the 5 that is on the top and on the bottom, we can simplify that. And that will end up with 1 over negative 1 over square root of 2. Agree? So as a conclusion, what is the secant of A plus B? Anybody? Negative square root of 2. Any questions?
You used the Paragon, whatever theorem to figure out that the square root of 10 is the hypotenuse, so there wasn't any trick to it?
Say again? Say again?
You used the theorem to find out that the square root of 10 was the hypotenuse for the B one up there? Or you just knew? I can't say the word Paragon theorem.
I think I understand the question to begin with, but let's remember that the secant of A is square root of 5. It's just like square root of 5 over 1, because whenever you don't see any denominator, the denominator is a 1. And from chapter 1, if we recall that secant is always hypotenuse over adjacent. That's how we knew. Was that good?
Yep.
Okay. Yeah, that's how we knew. It's hypotenuse over adjacent. That's how we knew. Any other questions? That was 38. cosine of x plus 3 pi over 2 cosine of x minus 3 pi over 2. The s to prove that is 0. But of course, obviously, the only side to work with is the left. You have a combination of formulas 13 and 14 to apply. First, formula number 13. This is cosine of x, cosine of 3 pi over 2, minus sine of x and sine of 3 pi over 2, plus, now we'll apply formula number 14 because we're dealing with cosine of a minus b. So this is cosine of x, cosine of 3 pi over 2, plus sine of x and sine of 3 pi over 2. We want that to equal to k. Okay, now let's remember now 3 pi over 2 is 270. So it's exactly on the y-axis, okay? Whenever you see cosine, the value of cosine will be what? 0. So this is cosine of x times 0 minus sine of x. Sine of 3 pi over 2 is what? Negative 1, because it's exactly on the y-axis. This is negative 1. Plus cosine of x, cosine of 3 pi over 2, 0, plus sine of x, sine of 3 pi over 2, negative 1. Let's simplify some more. This is 0. Negative times negative is positive sine of x. This is 0. Positive times negative is negative sine of x. Observe here that you have sine of x minus sine of x, which is what? 0. Which is what we wanted to prove. We're done with that. Questions? Next is 5-3. Double angle formula. See. And see, if you don't do well, if you do not study for chapter 5, forget about chapter 6. Okay? If you don't know these formulas I'm putting down on the board, and do not apply them, you're going to have a lot of problems in chapter 6. Because chapter 6 is just going to apply all the formulas that you've learned from chapter 5, basically. So, let's do that. Number 19. And then you will see, some of you will have a lot of problems also if you don't know those formulas from chapter 5 in calculus. Those of you who are going to take calculus, it's going to be a pain if you don't know them now. So make sure you know them really well. Double angle formula, right? Is that the topic? Double angle formula. So we have sine of 2a will always be 2 sine of a cosine of a. Number 20. Number 20 will be divided into 3 forms. I'm going to give you 3 forms of number 20, okay? The first part we'll give you is cosine of 2a. That's the first form. It is cosine squared of a minus sine squared of a. Observe it's not plus sine squared of a. It's minus sine squared of a. Part B of cosine of 2a. If, for example, you're looking at, and if you want to get this whole thing here in terms of cosine. You don't want to see any sine involved. Okay, that you can do. You will say this is 2 cosine squared of A minus 1. And someone may say, well, wait a second, how did you get that? Well, observe here, cosine squared of A minus sine squared of A. If you want that expression in cosine only, you change that in cosine. So this is cosine squared of A minus 1 minus cosine squared of A, because that's what sine squared is in terms of cosine. Getting rid of all the parentheses. That is 2 of them. Well, that should be understood for next formula that I'm going to give you. If I want to get it in terms of sine only, well, I just transform this into sine, which is 1 minus sine squared. At that, I will get 1 minus sine squared of A minus sine squared of A. Well, that will be 2 of them. So that's part C. This is going to be 1 minus 2 sine squared of A. Twenty-one. Okay, let me just put 21 up for those of you who are on the back. 21. What is tangent of 2A? Well, tangent of 2A would be 2 tangent of A over 1 minus tangent square of A. How do I remember this one? Well, I remember this one because I remember a tangent of A plus B. A plus A would be 2A. And that's A, tangent of A plus tangent of A, so that's 2 of them. Tangent of A times tangent of A, that's tangent squared of A. That's how I remember this one from this one. Anyway. That's what you need to know for this section. Let's apply then. Form section 5.3, we'll do the following so-called problems. And we'll see if they are really problems in a second. Six, 42 and 62. Yeah. How many exams did I say in the syllabus that was going to be given this semester? 5?
4 in the syllabus and you change it to 5.
Yeah, so after chapter 5, I will stop and give you an exam, okay? After chapter 5, I will stop and give you an exam, because when I looked at it, I saw that combining chapter 5 and chapter 6 for one exam could be brutal. So I've changed that, okay? Just to help out. Anyway, 20. very important to see where they put those angles, because your answer could change depending on where the angle is. Let's pay close attention to the angle. All right. Here you asked to find cotangent of 2a. Observe first that the idea of cotangent 2a, you don't have cotangent 2a. However, you have tangent of 2a. Flip that over, that's cotangent of 2a. Does that make sense to everybody? So cotangent, we can find it by flipping this one over. What's important here is to realize that when you look at tangent of 2a, you don't have any sign in it. You have tangent. But they gave you a sign here to worry about. So what do? Well, you have to go and pull out the triangle to see what's up. Yeah, that's what you're going to see. So now, sine of a, what's the formula for sine?
Opposite over radius.
Opposite over hypotenuse. Not adjacent. So what's the value of this side here? It's a special case triangle, 3, 4, 5. Agree? Knowing the one of the trig functions, we can pull out any other that we need with the triangle. That's the first thing. Given that the angle is in the third quadrant, where would your tangent be? What would be the sign of your tangent, I should say? Positive, because in the third quadrant, x and y have the same signs, therefore tangent is positive. So with that, I can pull out tangent of a, which is what? Wonderful. It's opposite over adjacent. Now I'm ready to find cotangent of 2a because I have everything that I need. Flip tangent of 2a over, and then I have 1 minus tangent square of a over 2 tangent of a. Now I replace them by their values. It is 1 minus tangent squared. It's 3/4 squared over 2 times 3/4. Now at this point it's just a matter of simplifying this expression, which is 1 minus 9/16. Put the 1 a little bit higher because I'm going to have to find the same denominator to combine them. And this one here is 3/2. Thanks. LCD is what? 16. Let's make sure that they all have 16 as denominator. Why? So we'll be able to simplify this one here also on the bottom. So from there, we're looking at 16 minus 9, which is what? So this is 7 over 16. And 3 times 8 is 24 over 16. We looked for the same denominator for both fractions so that we can cancel out the common denominator. At that, we are end up with cotangent of 2a to be 7 over 24. That is the answer for number 4. Questions? Next is number 8. Now they give you cosine and ask you to find tangent. Same idea. They give me cosine. To get tangent of 2a, I need to find tangent of a. So let's pull out the triangle. I have x here. Cosine is what again? Adjacent over hypotenuse. What must be this side? 3. Then I can pull out my tangent. What must be tangent for this problem?
Oh, right, 3.
Given that the angle, that's where this piece of information is very important. Given that the angle is in the 4th quadrant, how is your tangent? Negative. So this is going to be negative. So tangent of x is -3. Do we all see where we pull out the negative from? It's based on the information that they gave you about the angle itself, where it's located. So that's that. Then we can answer the question at this point. Tangent of 2x is 2 times tangent of x over 1 minus tangent square of x. So that mess is 2 times -3 over 1 minus -3 squared, which is -6 over 1 minus 9. This is -6 over -8. So we'll conclude that tangent of 2x is nothing but 3/4. Questions? Okay. That was number 8. 16. Yes, find cosecant. Well, they asked me to find cosecant of 2t. I don't have secant of 2t, but I have what? I don't have cosecant of 2t as a formula, but what do you have? The sine. Knowing that the sine of 2t is 2 sine of t cosine of t, we can find it here. But they give me only cosecant. Well, with that, I have to pull out my triangle. Cosecant is what again?
Hypotenuse over
Hypotenuse over opposite. So what must be this side? That. So we know this side, and from the sine formula, we know we need sine and cosine. So let's find sine of t and cosine of t. Sine of t would be what? What is that?
1 over the square root of 5.
Yeah, that. 1 over square root of 5. Now, just a second, before we move any further. You were told that the sine, the angle is in the 2nd quadrant. How is your sine in the 2nd quadrant? Positive. Your y value in the 2nd quadrant is positive. However, how is your cosine in the 2nd quadrant? Negative. Because your x is negative here. What is the cosine of t?
2 over the square root of 5.
2 over square root of 5. Okay, so we know that much. Let's go ahead and process this one now. Cosecant of 2t is 1 over the sine of 2t, which is 1 over 2 sine of t cosine of t. Let's replace everything by their values. It is 1 over 2 times sine of t, which is 1 over square root of 5. Cosine of t, which is -2 over square root of 5. So from there we have 1, and then the 2 that is outside is summed up by all the tops. So it's -4. Square root of 5 times square root of 5 is 5. So from there we can conclude that the cosecant of 2t is -5/4. And that's your answer for number 16.